So these are different choices, these are different cases. So what we can say is that 1 plus 2 plus 3 plus 4 plus 5, 15 cases, 15 ways in which B and A can be set. And remember, they cannot alternate because the direction is fixed. A has to be the left of B, which means B and A cannot switch their seats. So there is no 2 factorial here. Remember that, as we did in the previous 2 questions. But let's not forget the remaining 4% also. They also play a critical part in the story, though they are just standing idle. These 4% will take their 4 chairs in 4 factorial ways. In every single case. Just think of it. If B takes this chair, A can take any chair to the left of B, 3 choices and all. Whatever chair he takes, there are 4 chairs vacant. They won't remain vacant because the people who are standing will take those chairs. In how many ways? 4. And that will be true for every single case. So my answer will be 4 factorial into 15, which is equal to 360. Right? We understand this? So every single case, 4 factorial people will take their chairs. And how many cases do we have? Cases will depend on the number of ways in which I can make A and B set, which is 15. So 15 into 4 factorial is equal to 360, which is my answer. And we also learn an approach, a method, how to solve PNC questions. I call this method my own, not very innovative, but very inventive, which is what? Number of cases into arrangements per case. So I identify the number of distinct cases which has to be done manually unless and until I have a formula at my disposal. And for each case, the number of arrangement is same, which is 4 factorial in this case. So 4 factorial into number of cases, and there, while I have my answer. This particular question can also be done in a different way. Let's see if we can identify that different way. My presentation, my submission to you is 6 people are seated. In every arrangement, A and B will be there, right? And for the sake of decorum, let's assume they don't sit on the same seat ever. So they will occupy 2 different chairs. Now whichever 2 chairs they will occupy, now A can only sit either to the left of B or to the right of B. Right? This is not a very big concept to grasp. I am sure you understand this. A either to the left of B or to the right of B. Okay. Just think of it. These are alphabets, calculation and all. 6 people, how many ways? 6 factorial, 720 ways. Is there any reason why the number of cases where A sits to the left of B and number of cases where A sits to the right of B should be more or less than the other? Isn't it? It's all symmetric. So the number of ways in which A can sit to the left of B should be equal to the number of ways in which A can sit to the right of B, which means A to the left of B plus A to the right of B should add up to the all 6 factorial cases, which means in how many ways can A sit to the left of B? Total number of cases, right? 6 factorial, 720 cases divided by 2. A to the left of B, A to the right of B equal to each other, and both of them together adding up to 6 factorial or 720. So the answer should be 360. Okay, I hope we understand this, right? And related to this concept, there are a couple of examples that we will solve further. Alright? Okay.